sir. So thanks for coming out. My name's Casey Smith, as you mentioned earlier. I'm on the research team at Thinkst, and my colleague Jacob and I worked on this project. He wasn't able to come for this one, but we also publish a quarterly free newsletter where we look at different research papers, blogs, talks. So you can always check out thinkst.com/TS later on. Just a quick overview of what we want to talk about today. I want to talk about Canarytokens. What it is, it's an open source project. We'll get into some of the details. Talk a little bit about our research methodology, and really the long story short there is a lot of research is failure and just keep trying, and that's okay. Hopefully you can draw some ideas from that. And then what we built in this one is a very simple Canary token that alerts when a Windows process executes, and we borrowed a debugger technique and an attacker persistence technique to do that. So it's kind of an interesting life cycle for how we created this Canary token. And then we'll talk about what does it take, what are the challenges to go from I have this idea to actually delivering something onto an open source project and then supporting it and answering questions and sort of what comes along the way. So just a quick show of hands, how many of you have heard of Canarytokens? Is it okay? I see a few. Okay, great, awesome. So everything we're talking about today is on our open source project. I put the GitHub link there. There's other projects. A lot of folks either use our public site or they fork it and run it inside of a Docker container. You can run that anywhere. The thing that's interesting about Canarytokens, think of them like tripwires, okay? So those of you who haven't heard about them, these are documents or credentials or other artifacts, QR codes, that if an attacker stumbles upon it, they use it or access it, and you get a really quick alert. So I'll show you some examples of those. But really, a lot of what we've built our Canary tokens on is based on DNS and HTTP primitives. So if I can get something to do a DNS lookup, I can encode some data into that lookup and enrich the alert, and I'll show you how we did that. But they're really easy to use. We'd love for you to try them out, give us feedback. The things I'm going to talk about today, you probably don't want to do on your corporate machine because it may trigger alerts, so just be aware. I'll go over some of that a little bit later. But just so you can see what it's like, you can go to the website, you can create a token. We have one of our new ones that we created earlier this year is a credit card token. So we use like a virtual credit card API, give you a real credit card. You can put that in a spreadsheet somewhere. If someone ever tries to use it, you'll get the amount they attempted to spend, the merchant, and the time. So it's kind of really fun stuff that we're trying to create artifacts attackers are looking for, give them those, and hopefully they use them and you get the alert. And you'll get an alert, something like this. This is from our public website. You'd get an alert that would have things like the IP address, in this situation, maybe the username or the computer that actually they executed the command on. So one of our tokens that we created was an Azure login token. So this is really a fun one because attackers get into a network and they look for credentials. So let's give them some credentials. And so this is something that you would just put in an email or webhook for the alert. Give it some context about where you place those credentials, maybe on a build server, on a secrets manager, wherever you place those. So if that alert ever goes off, you can trace it back to a single point in time. That was on Casey's laptop. No one should have ever gone into that directory or that location. So if they're used, now you have a tip-off the attackers found those. And so essentially it looks like this. You create the Azure Service Principal login. Attacker finds it somewhere, tests it out. Maybe they pull it into their Azure CLI. They run it, you get the alert, and now you know that credential has been taken, and it's on our network, not your network. So it really decouples the risk there to get those really quick alerts that somebody is poking around. And it tells you a couple things. Not only did they find the credentials, but they tried to use them. And so when we think about deception techniques or tripwires, it's interesting to think about, we don't have to make it too complicated. So sometimes we talk to folks and they're like, well, we don't use, we have AWS keys or Azure keys, and they'll say, well, we don't use AWS. Well, that's fine, but attackers don't know that, right? It's kind of like the Home Alone model of defense. Just use what you have, put stuff around, the attacker will find it, they'll try it, you'll get that alert. So putting those artifacts in the network, some people put them in configuration files, documentation. So if nothing else, try it out, see what you think. It's all open source and customizable. Okay, so a little bit about research. When we decide we want to build a new token, we have some primitives in mind. So we're thinking, it has to be easy to use. It has to be very simple for people to deploy. And I'll talk a little bit about some of the failures along the way that we encountered trying to deliver this process execution token. And hopefully that gives you a sense of, sometimes when you see someone presenting their research, all you see is like the finished product. There's a pile of stuff that was either thrown away or not useful in that situation. But taking good notes and documenting your research methodology, you may find something that you come back to 6 months later that you explored and you had good notes, so you're not able to have to relearn all of that. But my colleague and I, we joke about the life cycle. So you have this idea, and then it immediately goes to this is a Nobel Prize winning idea. And then you realize you don't really know Windows. Maybe you have a Linux background, and then you sort of move up the curve to some happy medium where you find something that accomplishes what you hoped to create in research, and hits the mark, but it's not necessarily what you aspired for. So aspirations always outpace your capabilities. And so some of the things we tried in this, and hopefully you have seen some of these, but we tried things like DOS keys, and I'll go over these examples later, but DOS key, the Windows event log, scheduled tasks, NS lookup. We tried a bunch of stuff before we arrived at what we published in our open source project. All right, so failure, it's okay to fail. That's really the main thing on this slide is like inside of our organization, our research team, it's okay to fail, but it's important to document and communicate that. What I wanted to do, the outcome I got, in what the actual result, so that's an important component of any research project. I think some of you might agree. And also a lot of the things that we do are asynchronous, our teams all over the world. So that's true for a lot of organizations. So what did we want to build? And this is what this really talk is about. We wanted to help teams, small companies that maybe needed an alert if a command runs on an operating system that's sort of unsanctioned or rare, but they can't put EDR or other products or security products maybe on that. So maybe you have medical equipment or you have an environment like a build system that's ephemeral, so it comes up and runs, but you don't really want to wait to install the security products and rule processing because that system may only live for a short time. So what we wanted to do was if somebody gets on my network and runs, say, Who Am I, or NL Test, or System Info, or K-List. So K-List lists Kerberos tickets. That's a rare command for an ordinary user to run most of the time. And so we wanted to alert teams very quickly. So that was like our aspirational idea. And I borrowed some of the imagery from the book Skunk Works by Ben Rich, because it's a really good reference on the idea of the stealth fighter to the final product. So you'll see those throughout the deck. So how many of you have read DFIR reports? Or obviously you have internal information here, but if we look at a ransomware attack, and these timelines are absolutely critical, and sharing that information because we want to know what they're doing. What are they running? What command sequences? And almost always we see these commands show up again and again that attackers run. And so when we were reading and starting with this idea, we said, well, NL Test, how could we get a quick alert if that ran on a system that, say, wasn't instrumented with an endpoint product or was some system that NL Test really shouldn't be running on? And so that's sort of what we were going for, a really quick, high-fidelity alert that somebody's running a command they really probably shouldn't be, or it could be that early tripwire or like a smoke alarm. Something's not right here. That command is rarely run by that user on that computer. So you have to ask, how often does someone run NL Test /trusted domains? And so, again, could we build a simple alert for that? Now, I realize there's tools that do this. There's analytics that can do this. But again, keep in mind that not everyone has that instrumentation on every device. So I like this article from Brian Krebs. I don't know if any of you saw this, but it's a great analogy for this. And the idea is tourists only look up. So if you go to a big city and there's skyscrapers, the only people looking up at the buildings are tourists very often. If you've been there, lived there for a long time, you're not looking around. You're not trying to orient yourself to the sites. And that is very true also of network intruders. When they land on a system, they bump around a lot. And that's a really important primitive that we use when we build tripwires and honeypots. Attackers are going to poke around. They have to figure out where they landed, what system they're on, who they are, what they have access to. And that's a really great opportunity to to catch that activity when they're trying to enumerate system services or other components in the network. And so again, you even see attackers make typos and mistakes. So you'll see here again is another report. The attackers dropped Cobalt Strike, and then they run some net commands to enumerate groups, and then they misspell domain controllers. So there's a lot of things, opportunities here as they're enumerating, and this happens really fast. A lot of it's automated and scripted, so we want to make sure we get a chance to catch that they're running NL test trusted domains. I'm just using that as an example, but I want to know when that runs anywhere in my network, potentially. So again, in all these ransomware reports, if you go back and look at them, you'll see these common enumeration commands, common things that people are running. So again, the question comes back to how do you get that alert without actually installing a sensor, without installing a product? All I want to do is use Notepad and regedit. And so I'm a big proponent of living off the land techniques, even as a red team pen tester. Try to just use what's on the system. Try not to bring other artifacts or add additional binaries if you can help it. So let's start experimenting. So this was the early stealth fighter, half blue. They had to build something that actually could fly before they could build the final product of a stealth fighter. So then you start asking yourself, well, let's start experimenting. Let's figure out, well, what commands would be interesting to try and catch or alert on, and what's the easiest way to install. So let's talk about, so we have this idea, how do I actually bring it into reality? And so the two requirements or constraints are, first of all, it has to be easy. And again, we're not pitching this as something that you would replace EDR or SIM or other analytics. It has to be low false positive. We don't want people getting a ton of alerts. They'll just begin ignoring them. We want it to be a high fidelity alert. Someone ran this command. So we just started brainstorming in our channel, and someone had this idea for DOS key alias. Has anybody used this before or seen this? Some of you have seen this? Okay. So what this allows you to do is build macros, essentially. And so you could say, anytime I type in, I want Notepad to run. And so it's pretty well documented. There's some interesting macros and shortcuts you can use. And this was really our first glimpse of, I think we could do this. So we started really going down the path of DOS key. And if you notice at the top here, what we did was created an alias for scheduled tasks, SC tasks, and it expands out to run scheduled tasks, but in the background, in this example, run Notepad. And that was actually really close to what we wanted. An attacker runs a command, and then I want to run a command that generates the alert. So we thought we had it with this. This was sort of our first fail. We started building and prototyping this, but it turns out DOS keys wasn't great, primarily because if you wanted the macro to persist, you have to have logged into that system before. There's some additional complexity where we were finding it wasn't available on all the different systems, so it wasn't sort of global. It was constrained to that user's profile. So while it worked, we documented it, that DOS key wasn't going to be the thing that was going to be the one that triggered the alert for us. So we had to go back to the drawing board, try something else. The next thing we tried was, well, in Windows, you can turn on process auditing. Let's turn on process auditing and then just see when anytime the process name that we're interested in actually executes. And so this is really a cool feature. Actually, some red teams and attackers have used this before. Some of you may be aware. You can attach a task or a command to an event, and that's actually kind of cool. So if a 4688 event occurs, then run this thing, run this PowerShell script, run something else. The challenge we had with this, though, is it was just the volume. We had to then look at every execution, and then we had to look inside of the event and have a little query that said, is it NL test or is it K-list? In the end, we felt like this didn't meet the mark for simple and easy to use. So it was too noisy per event. It's absolutely a great auditing tool, to encourage small teams. It's free. It's built into the operating system. Definitely should be on. Didn't meet the mark for what we were trying to build, but again, a great way to use what's built into the operating system. So sometimes when you're researching, either as an attacker or a defender, sometimes it's important to maybe step out and take a different persona or different angle. And so one that I like is developer persona or attacker persona. And so developers, great, like debuggers and instrumentation. There's a lot of cool things that you need to check or introspect the state of the program. And then what would an attacker do? What might they, if an attacker needed to get an alert? And there's an interesting primitive where there's a real difference between someone developing an application and someone attacking the application. So as you're building the application, you're building it to meet requirements and specs and objectives. An attacker doesn't really care. They are more interested in what can I make that application do, and anything that's not explicitly denied is allowed. So they may want to use that program to run their command or inject their shellcode or whatever it might be. So sometimes taking a different persona can help you think about, it may just bring new ideas or open your mind a little bit to other approaches. So again, we're trying to think about that living off the land as a defender. I want something simple. So then we started thinking, is there anything that we know about like that red teams would use that might do this? And then we landed on something called image file execution options. Now, some of you will recognize this. How many of you have seen this before or used this? It's sometimes it's IFEO you'll see, but also this is something attackers have used in the past to persist. So the idea is I can attach an image file execution registry setting, and then I can get it to run my command. And that was actually pretty close to what we wanted. And then we got to this moment where like, that totally worked. Like I made a registry change for NL test, and if anytime NL test runs on that system, I can have it run any follow-up command. And so that was like, it's that moment where you're like, okay, this hits the mark for what we're trying to build. And so I'm a big fan of MSDN. Still called MSDN? Learning? I forget exactly. But anyway, the documentation is amazing. I love it. I read it all the time. But this is what we found. So in silent process exit, there's a few switches you can add here. And I'll go through these in detail later on, but you can do things like run another process. You can do a memory dump. You can get exit commands. Not all of that was important to us, but that was the thing really that gave us exactly what we needed. So then we started building it. So now, when you use image file execution options, though, if an attacker renames a file, it's not going to catch it. So if they rename NL test to ML test, you won't alert on it. But that's OK. Most attackers aren't renaming these files. They're just running them right out of the operating system, and they make an assumption that that command is not tripwired. So that's what we want to give them, is if they run NL test, it's going to send us a signal, and we know somebody's the tourist on our machine. So we actually will get into how we get this alert out using DNS, but we actually got, at this point we had it working. NL test runs, and it doesn't, the thing that's great about this is it doesn't break NL test. NL test runs fine, gives them the attacker the output. There's nothing that would really tip them off that we've tripwired that command. In the background then, when the process exits, my monitor process runs. And normally that would be a debugger or something that you might be instrumenting with. But in this situation, we're going to run a PowerShell command and have it do a DNS lookup. And encoded in that DNS lookup is the computer name and username. So now we know Casey ran NL test on workstation 75. Pretty cool. Except we tried using environment variables. So we started just using, basically computer name and username. And I'll show you how we do base 32 encoding for our DNS alerts in a minute. But it wasn't working. And so then we started digging in. So this is, again, another fail. It wasn't working because monitor process has this, %C that's actually a status code. And so we never could get around it. It was frustrating. It was fine. Like, obviously, we're using this for something it wasn't intended for use. But we had a collision here, right? We were getting %C in computer name, and it was giving us the actual. So we'd get like, 4187, was running this command was not what we needed. So not a problem. But we were trying to do NS lookup because NS lookup was available on older systems. So a lot of older systems don't have PowerShell, or they're not running. You guys are aware of some of the legacy systems people are still running. But what we wanted to collect was the username and the computer name. So we're going to encode this into DNS, and we'll just use PowerShell, and we won't use NS lookup. And I'll show you how we do that. So if you go to our open source site, a lot of us that work on these projects have a red team offensive background, and DNS just goes everywhere. I mean, it's amazing. Like, you can get out of almost any network. And so what we can do is actually use that as a defender as a very quick signal. And so we use a base 32 encoded string because there's no guarantee of uppercase, lowercase. We can't use base 64, so that'll be fine. So we do base 32, encode the thing. It would be great if we had a PowerShell native base 32 encoder, but it's kind of rare, so we can still get around it. And then we also had to remove characters that are not supported in DNS, but might be supported in a username or computer name. But we use this a lot for a lot of our alerts, a lot of our tokens and tripwires. A thing happens that then triggers the DNS alert. And there's some risk there because you get the IP address of the DNS server that looked it up, so you can't necessarily correlate that to the actual host. But inside your network, if you got a username and computer name, even though it was resolved from a cloud-based DNS server, you still know where that command actually executed. So this is cool. It was cool to us. We thought it was fun. And then the other thing you'll run into is usernames. I mentioned this earlier, spaces and things like that would not be supported in a DNS name. So we essentially lowercase, concatenate, and then send that over the wire. So again, not a replacement for SIM or EDR, but now we have a really cool alert for a command using image file execution options. And there's a few things that you have to be careful of. And I mentioned earlier, testing this on your work system is probably going to generate alerts. If you add this registry key with a PowerShell script, it looks suspicious to some telemetry. But also be aware of 32 and 64-bit registry. So we had this interesting case where one of the issues on our open source site was, hey, I'm trying to run nmap and your alert's not firing. And there's always something to learn in those errors. So we realized we hadn't accounted for the import of a registry into both to account for the two different types. But now we've got that on the document. So. And the other thing is just DNS telemetry and DNS analytics are amazing. I mean, you run a DNS command for a new domain on Canarytokens and you'll get 15 lookups. And our theory and our idea is there's a ton of DNS intelligence. People are looking for newly registered domains they haven't seen before. And that's okay, that's fine. We can deal with that. We just have to suppress the number. So if a query comes in that doesn't contain our random string or comes in at a certain interval, we can suppress that so the user just gets the one alert. They don't get bombarded with 15 alerts for that one command. And also the other problem is you always have these assumptions that no one runs an L-test. And then there's that one environment where they have some automation tool that runs it all the time. So if you're going to use this or recommend it to people, just be sure you're aware of the frequency of commands and you're not going to bombard someone. And also, don't use command or PowerShell because you'll create an infinite loop. So I'll go over that in a minute. Because then you have So the end goal, right? Remember, attackers land on a network. They're going to run almost always NL-test or system info or klist or something. So I want an alert that tells me that has run, and I want to know the user and computer. So what we ended up with was something like this. And it's all in our documentation, but essentially we take the computer name, we put a marker between it, and then we put the username, then we mark it as a CMD type alert, and then we have a random string subdomain at canarytokens.com. Once we get that alert, that triggers you an email, and you'll get an email with something like what you see in green here, that this computer, this user ran this command. So it ended up being really awesome and very helpful for some environments where they were able to deploy this. So in the end, what this token looked like for us, this is just one example of our Canary token, is it met the bar for easy to use. We create a registry file, and a defender can just simply say reg import and the file name, and then anytime that command runs, what I was trying to show on this slide is it runs fine, doesn't interrupt their operation, but in the background, when that exits, you get the PowerShell running and you get the alert. So if you're concerned about or have sensitive usernames or host names, those are in clear text in the alert. This is not a great token for you for that. But you could add a little logic if you wanted to abstract that, et cetera. But for most people, they just wanted the really simple alert. But just be aware that it does expose a username and a host name in clear text. So at this point, when you think about the research, we've done the work where we know that we want to create this registry key to monitor this command. Now we're ready to ship it into the open source project. And I wanted to kind of switch gears and talk about what does that look like to go from, I've got the idea, the research is completed, how do we hand it off? So again, following this life cycle of the Nighthawk. Essentially, they had the idea, they prototype, then they build the first working one, then they ultimately have a final product. And these slides will be available later on, but you're looking for candidate commands here. So you're looking for things that run low frequency, but have an association with an attack or, say, ransomware. So commands that are not great for this are things like command and PowerShell, or even Outlook. For example, Outlook opens and just stays open for most people. But better commands are short-lived commands, enumeration commands that run, they exit, and that triggers our tripwire. And then, in terms of creating it, you simply go to the website, put in your email or a webhook, and then that can kick off a whole workflow for folks, whether they get that alert in Teams that kicks off a different workflow, et cetera. It does require administrative permissions to install the registry key, which we think is fine. If you're a defender, you have that permission. The other thing that's interesting here is this works even if the file isn't present. So in a lot of reports, attackers bring tools. So they bring adfind.exe, or they bring sysinternals tools. And you may or may not use those as a defender. So if you're concerned about someone running adfind.exe, you can create this registry key and it just sits there. Even though the file is not there, if it lands and execute and they haven't renamed it, they'll set off the tripwire, which is also very helpful. Again, just be aware if they rename it, you won't catch them, but again, just a caveat. So what it looks like then, sort of the final product, and I'll take you through what it looks like for folks that use this on our open source site. You would go to the website, you would choose the sensitive command token, and you would go ahead and put in your email or the webhook there. And this is probably the most important, is add some context here. So you want in that memo field something that's going to help you investigate that alert. Why is this command important? What's the context? Who do I contact if I get this alert? And then you just simply put in the binary you're interested in monitoring. What that does then, it creates a registry file that you can download. And I'll take you through what that looks like, just so it's not magic. It's just essentially we've used the image file execution options with the debugger flags here. So this is what it looks like if you were to open it in a notepad. It looks a little bit scary for folks when they look at that monitor process command, and we're just doing some regex there to remove the non-DNS characters and change case and stuff like that. And then at the end is the DNS lookup for the alert. So what does that 200 mean? Well, essentially, when you set that value, hex 200, that actually turns on monitor silent process exit in the image that executes. And then within that, there are a few other flags that we can use that are interesting to us. So the launch monitor process is the one that's going to then spawn something else. Inl test runs, and then PowerShell runs with your alert. But there's some other interesting ones here, like dumping memory and also potentially notifying the user. Some people can turn that flag on as well if they're interested. And then this was the key, and again, the documentation is important. If you saw the talk earlier, I think it was maybe Wednesday, they were talking about attacking RDP just by reading documentation. So it was awesome. But again, this is what we've got here. We're essentially monitoring the process, and we can put the command line parameters and embed that into the registry, and that will then execute. So what we were able to do for folks is create a very basic debugger/attacker persistence technique, and then use that to tripwire that executable to alert us anytime it runs. And so one registry key, essentially per file that you're interested in monitoring for, and you could deploy that to all the different systems. Now I know that's not the purpose of that registry key, and that's not the main use for it, but essentially for us it was helpful because we were able to repurpose that and use it and let people know this is a really quick way you can get a command alert, and no one, you don't have to install anything. You just need to add this registry key. And what does it look like? So you get the alert. In this situation, you would get the alert coming in over the channel, get that it's the token reminder. In this situation, you've maybe instrumented ms build, another common command that can be used by attackers to run different backdoored projects or C# tasks, etc. And then there's some other artifacts. So some of you may also be interested in looking for this if an attacker is using it, or validate as a defender. So there's a few other alerts. So again, I talked earlier about 4688. You can correlate that process ran. And if you need to enrich that alert, you got the alert that NL test ran, and you got the username in the computer. Now you may want to work backwards, and this is where having that event log turned on can give you things like the parent process, additional context about process permissions and things. Further, what we found was there's this really nice event log 3000, which actually also correlates to a silent process exit event running. So those are very helpful as well for teams that you got the alert and now you needed to go investigate or find additional information. All right. So administrator installs this on systems that they have permission to. The user runs the command. Again, I mentioned this earlier, but you can reuse that .reg file, import it onto a number of different systems. And again, keep in mind the short run or short-lived commands, those enumeration commands. Who am I? We actually did an interesting blog recently about the default settings. And so we had who am I as an example. And turns out people, when they read the documentation, they'll a lot of times just use what's provided in the examples. And so who am I is actually not a great command. That was one of those fails where you might think it doesn't run very often, but in reality, there's maybe a lot of automation or tools that run whoami.exe. And you don't get additional context with this alert, so you don't get the command line or process heritage or ancestry. You just get the command name. But it's still, for some folks that have these third-party systems where they can't install their security products for whatever reason, they can add a registry key. They could instrument it with this. Mentioned this already. Talked about, again, something that doesn't live on the system, AD find, for example. Lightweight, easy to use alert. Now, in terms of demo, I thought since when we're done with this, we'll be in the village answering questions. I can show you how this works on the laptop. So I won't do a live demo here, but I'll definitely happy to show you any of the other tokens. But I hope that was helpful in terms of thinking about a life cycle of, like, here's an idea. I want to use this to help folks to get those quick detections that maybe ransomware is occurring or an attacker's running enumeration commands. And again, some closing thoughts. We can take something that was designed as a developer technique, and even though attackers have repurposed it, as defenders, we can live off the land too. We can use anything that's on the operating system as fair game to set these tripwires or backdoors to make the attacker think twice before they run a command or use that Azure credential, and so we can devalue those. So these are free to use, like especially you can create as many Azure credentials as you want, put them all over the network, and then the attackers, we've literally had feedback from red teams where they're like, I don't even know. I landed on this network and I'm not sure if I should use that because maybe it's a token or a backdoor. So hopefully one of the outcomes of this talk is feedback, talk to us, try it out, see if you like it. If you hate it, I'd love to hear about it. That's how we get better, by sharing these ideas with the community. Check out canarytokens.org to generate other types of Canary tokens that you can use. All of that's free. It's on GitHub. And just a shout out to the team. Things never happen as an individual. If you have an idea to production, it's always more than just one person. And then lastly, some of the books that we like to read. Some of you may have read these books, but I really like these. They're really interesting books about that intersection between engineering and research. So Loonshots, Right Kind of Crazy, Skunk Works. It's just really good to hear from other folks about the challenges that they run into. And it's important to draw from other domains. So in cybersecurity and technology, there's other disciplines, healthcare, aerospace, that can give us ideas about either safety or challenges and how they innovate. And I just find these to be really useful. So with that, I think that's all I had for you folks. Thanks again for having me out at BlueHat, sorry. Too many hats. Thank you so much. I appreciate it.
Thank you so much, Casey.